a podcast about the intersection between humans and technology. My name is Guthrie. I'm here with Susan. Hey, Susan.
Hi, Guthrie.
And we also have with us one Mr. Dean Barker.
Hi, Dean.
Hello, Susan. Hello, Guthrie.
Continuing our series.
Our never-ending series.
We're still doing objects and views.
What?
Are we still doing objects and views?
Dean's got the He's
yes.
not. Yeah.
Okay.
Dean's got
so
the
this is
agenda.
We're continuing the I don't know, your guys'
exciting conversation.
Musings on objects and views. How's everyone doing today?
Good. I have, though, unbeknownst to Dean.
Oh.
It's always a bad start.
I have something I want to kind of, I don't know, argue about. I don't know, discuss.
All right.
But it doesn't have to be at the top. I can say that, and then you can worry about it for the whole podcast.
You're going to weave it in.
I am. I'm going to kind of see where we go. But there is a discussion I would like to have. So at some point, we'll have it today. And you have no idea what it is.
I'm ready for. I've worked with you long enough. I know I'm ready for anything. So.
Okay. All right, Dean. Where did we leave off last time?
So
this is number 3 or number 4?
4.
Number 4 on this topic, where we've been going back and taking a historical look, or a hysterical look, depending on your view of it, about technology and hardware and software. But because we were wanting to talk about the idea of object-oriented user experience. So where did we leave off, and what do you want to talk about today?
So we left off in the last episode with communities of practice and programmers and designers being from Mars and Venus, or maybe it's Venus and Mars, I forget the book, but being of different ilk in different communities. And we were talking a little bit about how object-oriented programming and object-oriented UI design are not the same thing, similar but different. And so I wanted to go into some modest technical detail about what object-oriented programming is.
Okay.
And then I think we can get to the nitty-gritty of UI objects. So maybe I'll start with the programming side of the fence, and then we can segue, and you can take over on the object view stuff, and we can get to the details about that. Sound good?
Sound good.
All right. So just to follow up on the history lesson, object-oriented program is related to history in as much as there was, I think it was in the 60s, a program from some Scandinavian research institution called Simula that led to the development of Smalltalk. And there's a lot written about the early history of Smalltalk, but
which is like a programming language.
It is a programming language. It's often credited as being the first object-oriented programming language. It's not. Simula was. It preceded it and informed it. I suppose in part, we've had this phrase that I stole from Theo Mandel, object-ish, right? I suppose it was in part more object-ish than truly object-oriented, but nonetheless, certainly Smalltalk popularized the whole idea. Mm-hmm. And so if you think about the history of programming languages, you've had BASIC, which a lot of us of my generation kind of grew up on. That was the first thing I learned to program in. C, Pascal, Fortran, other languages prior to Smalltalk. Smalltalk is really the language that created the movement around object-oriented programming. And then out of that came C++, came Java, came Python, which is probably the most popular language now. All of these things come out of the constructs that Alan Kay and others developed at Smalltalk. We'll get into the technical-ish details and away from the history. The thing that's important about the history really is that Smalltalk came out of Xerox PARC. So in our story about the evolution of UI technology, UI thinking, user experience design, again, Xerox PARC plays a part in that on the programming side. And so, what is object oriented programming? Object oriented programming is like object oriented design, it's a way of thinking and doing work. So, within that community of practice of programmers, developers, engineers, lots of synonyms in our world, there's a way of thinking about programming based on the older languages, like I mentioned, and then based on the more modern languages. The more modern languages are object oriented, in contrast to what were described as procedural languages, right? And so, if you think about when you code, if anybody's ever even seen in a movie lines of code on a screen, they're done in blocks or units, right? And what are these chunks of code? Well, in the earlier ways of thinking, it was procedural. So procedures, also called functions, methods, subroutines, are basically statements. So for loops, while loops, Boolean logic, things like if then else statements, that kind of thing. And so procedural language divides the programs into these smaller chunks, refers to them as functions or procedures, and it's a set of instructions. Do this, do this, do this, do this, do this, and it's all based on logic. So procedural, you can think of the procedure, literally stepwise. Object-oriented program divides the system or the units into objects. And so an object is a code structure that is reusable. It's stepwise, or it's not stepwise like the procedural. You have these objects, and the way that work gets done in the program is that the objects pass messages back and forth. They essentially talk to one another. And so this was pretty novel and groundbreaking when it came out. So you've got this idea of an object which takes the states, the methods, the attributes, the behaviors of that thing, that object that you're creating in the code, and contains them all in that chunk of code. And that's the idea
So,
of encapsulation, which is
can
a big principle here.
can you give an example of what an object might be? Just in object-oriented programming, I might have
Yeah.
an object called.
Yeah. So, you think about in the healthcare space, you might have patients, right?
Mhm.
And you might have insurance companies, and you might have
So
bills or
the
statements,
object
right?
patient is going to have all kinds of stuff associated with it, and so when I'm writing my code, I'm going to be talking about what to do with particular objects.
Exactly.
And
And
yeah,
importantly, how they relate to other objects, right?
right.
And did you guys talk about databases yet?
We touched on it. Well, we're
But
definitely going to come back.
I should just add briefly that one of the things that helps make the whole mental model of object oriented stuff kind of make a little more sense is the idea, just thinking about how data is stored in software, because there is data and it has to be stored somewhere,
Right.
and this kind of low level stuff, you can't automatically just store anything you want like it's a Excel file or something. Like certain data has to be different types, certain data has to be formatted a certain way, has to be accessible in a certain way. And so chunking data that sort of makes sense together helps sort of make everything smooth.
Yeah, which is done in an object, but, and there's a big but
Yeah.
in there, in the evolution of database thinking. So relational databases, which is where I started my career, relational databases stores data in tables, and those tables relate to one another. And so we'll talk a little bit about the thought process, but to kind of get ahead of ourselves a little bit, that thought process of thinking in things, right? We talked earlier about nouns and things. It's the same process that database designers go through in terms of creating entity relationship diagrams, right? So you've got patient, you've got appointments, you've got all these things. How do they relate to one another? You have to structure that out and think about the logical relationships. Same thing in object-oriented programming that they do in database programming. There was a movement towards object-based database applications. I guess I might be misremembering, but I think it was in the 90s, that didn't really take off. And the computing history that is not really talked about with that is the reason that it didn't take off is because of legacy code, legacy data. That all these companies that wanted to move to the shiny new object-oriented databases would have had to completely rewrite things, would have had to completely migrate tons and tons of data, and it would have been just Herculean efforts. And so you actually have object-oriented programs that do talk to relational databases, right? So it's not all, nothing is clean, right? It's a, Susan, as you say all the time, it's a muddle, right? There's kind of a muddle of technology and even paradigms in here, but nonetheless, in its pure form, you've got objects that encapsulate all of these things. And there are some other constructs that are important with object-oriented programming, these characteristics like abstraction, inheritance, polymorphism. We won't necessarily get into all of them because I know we want to get to the UI stuff, but these are important programming concepts. I think the two that are most important as it sort of transitions into what we really want to talk about is this notion of abstraction and inheritance. So, Susan, you talked the last time. I'm trying to remember the story that you told. I did have some notes here. Where's Susan's story?
About when I was taking my programming class.
Yeah. There was an employee vendor situation. So
Yeah.
you were talking about working for a client that had created objects that included employees, vendors, customers, that sort of thing. And again, it's the Mars and Venus. You're
right, because they had one object, which to them was people.
Right.
And so when they were going to do part of the programming and create screens that had to do with anything people, whether that was an employee or a customer or a vendor, they were using underneath all of that the same object, which for them, which was the people object.
Right.
And when we were designing the interface, we were talking about user interface objects, and we had from the user point of view, there was an object which was employees, and another object that was customers, and another object that was employees, that was vendors. And those were three different objects from the interface point of view, because the users definitely don't think of those three things as being the same. And at first, so we had designed, the interface, taking this object view point of view that, we talk about in interface design. And then we're trying to have a conversation with the programmers about what we've designed. And there was just like, they were confused and asking us questions, and the questions didn't make any sense to us. And it was like, we're talking, like you said, is Mars and Venus. It's like we couldn't even figure out what the issue was until I asked them about the programming side and found out that to them, this was all the same object. So they didn't understand why, we kept saying, well, we have these three objects and these different views of each object. And they would go, no, you have one object. And we'd go, no, we have three. And this just went on and on until I realized why we weren't communicating. And as soon as we surfaced that and they understood, then it was like this big aha moment on both sides. And then we could talk together, because then they knew what to do. They thought, I think they thought we were asking them to change their whole underlying object programming structure. And we weren't.
Right.
I was, and this comes back to what you said, which is they're related. Object-oriented programming is related to object-oriented interface design. There's definitely a point at which you have to connect the two, but they are not the same. And it reminds me of the other story I always tell, which is about, Disney. And if you've ever, and I've not been able to do this, but I've talked to people who have. I don't know if Disney does this anymore. At Disney World, they used to have special tours that they would bring you in and show you what's going on underground.
Interesting.
Because, at Disney World, there's the part the visitor sees, which is above ground.
Right.
And that's where all the magic is. But underneath that, there's an entire world literally underground. So if you're one of the characters, for instance, at Disney World, when you come to work, you come in a special entrance that takes you underground. And everything you do is underground. And you go there and there's food vendor, there's the cafeteria and there's the locker room, and you get into your costume. And then there are special places where you kind of magically appear above ground. So there's a whole underground world that makes the Disney World work. Disney World is the part that the visitor sees, and it's not real.
Right.
Okay. And then there's the stuff underground where everything really happens. And that's what I always use that as an example of interface design, because the interface that we create, that the person interacts with on the screen or with the voice or whatever, it's not real. It's pretend. That's okay. That's good. And I think sometimes if your mindset is as a programmer developer, you're like wanting to bring up to that interface level all the things that are going on underneath. And it's like, no, don't bring it up. We don't want to see all that stuff. We need to create the fantasy world of the interface, and it's a fantasy. It's not what's really going on. It's okay, but it's beautiful, and it's a nice experience, and it's interesting, and it's fun, and it's easy to navigate through. And then the two sides, the programming and the interface designer, need to get together and make that translation so that the interface designer knows enough about what's going on underneath to deal with the technical issues that the software developers have trying to do what you're asking them to do, right?
Right.
But then the software developers have to understand the fantasy you are trying to create and help you create that fantasy. And I think sometimes we don't have that conversation, and we're not willing to work with the other side. And I also think the more you know, I mean, if you're an interface designer, you're not going to be a programming specialist, probably. It's really hard to keep up on both points of view and both bodies of knowledge. But it's very helpful, and vice versa, but it's very helpful to understand enough about what the other side is doing so that you can have these meaningful conversations and clear up misunderstandings that are going to occur. All right, that's my rant.
No, that's a great rant, and it brings up a ton of really important ideas and issues. And if we kind of work backwards, that whole idea of the fantasy of a system, the imagination of a system, right? That we talked in, I think, the first episode in this series about mental models and conceptual models.
Yes.
Right. And so as communities of practice, as human beings, developers are going to have a mental model about a system. Designers are going to have a mental model about a system.
Yeah.
Ultimately, the one that matters is the end user's mental model. But there is this imaginary world that you can think of as logical or conceptual. How we understand that and communicate it to one another, communicate about it with one another, rather, in the work that we do to produce software is vital. And since we do have different paradigms, different tools, different ways of working and thinking, we have to reconcile that, right? Because it's not just that imaginary versus real world, it's that logical or conceptual versus physical world in both these communities of practice, right? Because the programmers are going to do their work. They're going to think in terms of objects and classes. I want to come back to classes here in a minute. They're going to think in terms of objects and classes and doing all the work of managing the procedures and the data and everything within their code. And there's a physical reality to that code and how data is pushed around, back in databases and things like that, as we discussed. That's a very physical, real thing to them. That's not just a conceptual or logical model. Similarly, we have our conceptual logical model, usually done with boxes and arrows. You can use UML diagrams, that sort of thing, and get more technical. But ultimately, what we do as designers is manifested in screens, buttons, tables, widgets, forms, whatever, right? And so we both have a conceptual and physical idea of the thing, and that all has to be reconciled. So that's what cross-functional work
That's
is
why
all
it's
about.
so hard.
That's why it's so hard. That's right. Well, it's like, what did I read? I think it was like a therapy thing, psychology for relationship problems and whatnot. And something like 70% of marital problems are never reconciled. Right. So like you have to get good to have a relationship at not reconcile those things that are reconcilable. Right.
And let the rest go.
And deal, just like cope, right? Like what do we do as human beings? We cope, we manage. Well, in our work life, it's the same thing. You're not going to be able to reconcile everything. So you have to, as you've said, muddle through it, right? But you have to find good ways to articulate this. It does help if you are in an object-oriented environment, and it does help, as you've said, if you understand more of the technical issues so that you can communicate with engineering groups. But, it's a heavy lift. I've talked to my students at the university that I teach at about this, and they want to know, well, what do they need to learn beyond their program or whatnot in order to do well in the industry? And the answer is everything, right? Like it's such a heavy lift to understand all of these things. Our field alone, user experience, if that's the phrase we're going to use, is interdisciplinary, right? You have to know something about computer science. You have to know something about anthropology. You have to know whatever. Those are all the big disciplines that play into it. You can't know everything about all of that because within user experience, well, you have to know interaction design. You need to know enough visual design or color theory if you're an interaction designer, or vice versa. You have to understand research with qualitative and quantitative. You should know something about accessibility. You should know something about mobility. You should know, it keeps going on. And every so often there are trends in the industry, I think, where things that used to be optional or novel or specializations now just become part and parcel of doing your work. And like there's a whole 17th graduate degree you need just to function.
But one thing I want to say, which I know I'll try to make this brief because it's so easy for us to go off topic, and that's why we're on episode 4 of this topic. Guthrie's like, yes, I was just going to say this.
I'm in no rush at all.
Okay. One of the things that, if I think back on and literally thousands, of projects that I've consulted on in my career, one of the things that has been an indicator of whether this project is going to go well and be successful, and we're going to end up with an interface that works, and we're going to end up working effectively, the UX team with the software developers, is there's things going on with the project and the people, and based on what's going on, I can predict pretty accurately whether this is going to be successful or be a train wreck.
Right.
And one of those things is there someone on the team, on the software engineering side, that enjoys the challenge of figuring out whether we can actually do some of the weird things that the UX people want us to do. Like how, they don't think if everyone thinks of it as, oh my God, I can't believe they're asking us to do that. And that's not
Right,
going to
right.
work because of this and that. If everybody is just like rolling their eyes and thinking these people are a pain, versus there's one person over there who's like, oh, I don't know, I bet we could do that. If we just thought of it this way, that thinks of this this relationship between the UX people and the software developer as a fun challenge,
Right.
right? And is interested in how might we do things slightly different and get that result. If there's one adventurous person, then the project is likely to be successful, especially if that adventurous person is highly regarded by the other software
Right,
developers.
right.
That's important too. So yeah, no, there's it's really interesting. I've always said, um, you were just talking about all the things you need to know, and you can't. I think it's impossible to focus on either software development or and I don't think it's possible to on a particular project to be a software developer and a UX person, because I think you need to focus. You might be able to switch back and forth on the projects. However, if you can forge a good relationship, and if as a UX person, you know a little bit about the software development environment and programming tools that this project is using, that's very helpful. And on the software development side, if you know a little bit about UX and the UX, prototyping tool that they're using, that's really helpful, because then at least you can have a meaningful conversation.
Yeah, and I think that begins wherever it needs to begin, right? Like there's,
Oh, that's a very Yoda-ish.
well, yeah, there you
We
go.
Yes,
Because
we
here's the
must
thing.
begin wherever we need to begin.
I think it would be begin we must. Anyway,
Yes,
yeah,
there you go.
subject, object, verb. Uh, but I think it's like with parenting, right? Like you have to, particularly as they start to get adolescent and teen, and as I'm now finding out, which you've already known for years, college years, uh, you have to meet your child where they're at with certain things,
Yeah,
right? And so in any relationship, if you're the one actively trying to pursue, an exchange and improvement, um, and facilitate that, you have to begin with wherever the other party is at, right? And so
yeah,
I just think that yes, the more that you know about engineering, the easier it's going to be to communicate.
right.
But it's also a two-way street, right?
Yep,
So there's some of that that's in order, and while it's helpful for communication, it doesn't necessarily. It can, but it doesn't necessarily uh, exponentially make you a better designer, right? There's enough
right.
specialization work
Yes,
and enough things
yes.
that we have to worry about from a
No,
design standpoint.
it's more about the communication. In fact, I think if you know too much, it'll distract you.
Yeah,
All right,
yeah.
go. All right. So I'm sorry I detoured us.
No,
Go
no, no.
back to where you were.
Well, we were talking about objects, and you told that first story pre Disneyland
Yeah,
about the client and kind of talking past one another. And so
yeah.
I think what you were touching on there is this idea of a distinction between objects and classes, right? And it gets
Mhm.
back to if we go back to kind of our agenda about object-oriented programming and some of the key characteristics of it, such as polymorphism, encapsulation, abstraction, and inheritance. Let's take those last two because they're going to play into our transition to UI thinking. From a technical standpoint, you can have an object and you can have a class, right? And so customers and employees might be objects, as you said in your example. People would be a class.
Mm-hmm.
right? And there is this idea of inheritance where, for
Mm-hmm.
example, customers and employees all have an address and a phone number. They have these
Mm-hmm.
attributes that get inherited from that higher order of thinking, that higher level of thinking about the thing,
Mm-hmm.
right? So object oriented thinking is in part taxonomic,
Mm-hmm.
right? That's part of the whole deal about the thought process of thinking that way. And so while there are benefits from a certain structure that you might have from a technical standpoint, that may or may not map precisely to what you need from
Right.
a design standpoint.
Exactly.
And that's the challenge. But this, and I think one of the things that we need to think about is in these conversations, um, where do objects come from? And if you think about the whole idea of a business narrative, however you're going to
Yeah.
manifest that in
Yep.
in
Yep.
use cases, in requirements, specifications, and user stories. As a user type X, I want to do Y so that I can Z, whatever that is, right? You're going to capture these things. They're generated from the real world, from the world of business or whatever context we're in when we're making software. And that ultimately, it's way back when we started this series, uh, way back now. That really comes from language. This whole idea about the language that we use to communicate. So, for example, we just we just bought a new truck. We just bought a new SUV. Right? Went through the whole process and went to 6 different dealers and looked at different options and all of these things. And so my wife and I, and we're talking to the kids about the whole thing. All right, next weekend, this is managing expectations, right? This is what we're going to do, kids. Everybody pile in and we're going to spend the day looking at cars. Well, we would say we're going to go look at a new car. We're going to go look at a new minivan. We're going to go look at a new SUV or pickup truck or whatever. Never once in that conversation did we generalize to say we're going to go look at and purchase a new vehicle, right? The word vehicle never entered
Right.
our lexicon because we don't think that way, right? So, we talk about kind of top down in engineering about classes and objects, but really how these things are derived uh, isn't from the inheritance and thinking at that level of abstraction. It's the other way around. It's getting to sort of the primary objects that are in your user's world and then generalizing up, right? And we do this on the design side as well as on the engineering side, but those models are different. So it's an
Yeah.
analytical technique,
Right. And I think this is one reason why it's easy to end up with interfaces that are not that don't match the user's mental model if in fact the software engineering team is working off of what business is telling them to do, and if business has their view of the world which is not the same as the user's view of the world, right? Then what you end up with is you end up with all the programming code stuff bubbling up into the interface, and you end up with not just, objects, but what things are called
absolutely right.
being based on this view of the world. um that, and it's interesting because you can have a view of the world that the software engineers have, you can have a view of the world that the business has, and you can have a view of the world that the user has. You can end up with 3 different views of the same world that don't look at all alike and don't have the same terminology, and then you wonder, why do the users not able to do this thing?
Right,
Why
right,
are they having such a hard time? Well, nobody's agreeing on what these things are, or they're using terminology like vehicle,
right,
and vehicle, it's like, okay, and it's interesting, it's like, okay, vehicle appears on the screen and that's not, I'm thinking about truck. I can probably figure out pretty quickly what you mean by vehicle, but should I have to?
right.
And we take that little few seconds and of disorientation, and then we add it with a few more seconds over here because you called this, and it's all these things. I always say it's not just there's usually not one thing I can do to tell you to make your product usable. It's this combination of all these little things that you didn't do a good job at in terms of matching the user's mental model, that now you have something that is hard to learn and hard to use. And then you put on top of that, it's not just something as simple as calling something vehicle instead of a truck. It gets even, much more deeper in this conceptual model where you've got, objects and views of objects that are really far away from how the user is thinking about it. It's like, that's how the company is thinking about it. But, the company's view of the world doesn't always match the user's view of the world.
Without a doubt. And so this idea of different models, different mental or conceptual models, even different physical models for the things that we create is a real problem, because you've got what we're doing from a user experience UI perspective. You've got the application and the programmers that are potentially dealing with an object model from that perspective. You may have a related but slightly different entity relationship diagram representing a database model for those who still think in that way. And all the, as you said, the definitions of the things, some sort of data dictionary, some sort of glossary from a natural language perspective on the design side, whatever, all of these things. You might have a domain model that exists, for example, at an enterprise level, which is here's how we talk about healthcare or finance or CRM or whatever. There are industry domain models that are generally accepted in certain contexts as well, and that sort of thing. And all these things need to be reconciled, because at the end of the day, you're creating something for somebody to use in the real world. So I just want to transition into our UI thinking, but to set that up, I want to go back to this idea of object-oriented programming and the paradigms, because in object-oriented programming, that is in contrast to procedural programming. So there's the distinction. In object-oriented UI design, the distinction is between that and application-oriented design. This goes back to the Windows OS 2 thing and how we've ended up in sort of an object-ish kind of paradigm. But those are the paradigms, and if you look at the literature, that's kind of those are keywords to look at. But this idea of objects being generalized as classes are a blueprint or a template for an object. One thing that I want to say about that, this applies both to the engineering side of the fence and to the design side of the fence, especially the design side of the fence, is that there's not necessarily one right answer to what that model should look like. These things are subjective. So you've got this relationship between classes, objects, and instances. If I'm thinking about, I don't know, mail order food service, and I've got cakes and I want to sell pound cakes. Well, I've got cakes as a class and pound cakes as an object, and orange pound cake with vanilla glaze that I'm going to send to you when you order it as an instance of that. That's subjective. You could just as easily say, well, dessert is a class, cake is a subclass, pound cake is an object, orange pound cake is a sub-object, whatever, right? Like you have these relationships that are not necessarily arbitrary, but certainly subjective. And again, that gets matrixed out because you're talking about that with 3 different communities, perhaps, or more, that have their version of that thing. So the level of complexity is insane.
Right. But the thing is, okay, yeah, I absolutely agree with you. And so what's important when you're doing this object-oriented design work is to understand, as you said, it's complex. There isn't one right way to do it. There are multiple ways to organize this conceptual model. And however, what the decisions you make to do it this way versus that way have real impact on what the interface ends up looking like and acting like. And so you have choices that you have to make. And there is no one, there's not just one interface that can come out of that. depending on your choices. There's a lot of different ones. I like to say there's no one way to do it, but some ways are better than others when we're talking about, ease of use and ease of learning and even ease of programming. So, you want to talk through and think through your decisions, and test out your decisions early, so that you can find out. It's like we think it's a great idea to call it dessert, or whatever, and
Right.
or to call it pound cake, and and then when we test it out, it's like it's like, why is there a special category called pound cake? I mean, why isn't that just a cake? Or why is it, why is it that way, right? You need to test out your decisions about the conceptual model, before you program the thing, to find out, oh, wait, the way we're thinking about it is not the way the users are thinking about it.
Well, and that's right. You have to meet the users where they're at. Again, meet them where they're at and understand their mental model and their language. So I've got a funny example for you on that. Do you like cheesecake?
I do.
All right. Describe
Big
cheesecake for me.
fan.
Guthrie. Let's bring Guthrie into the conversation.
Oh boy,
Guthrie,
see, this
describe
you've made a terrible mistake.
Why?
Because because not all cheesecakes are the same. So this is right. So
generalize. What is a cheesecake? If the aliens came down to Earth,
okay, all right, that's
how
good.
would you describe cheesecake to them?
Guthrie?
Oh, you want me to go first?
And let's say the aliens knew of cake and they knew of pie, but they had never experienced a cheesecake. Let's set those parameters.
So cheesecake, it is the problem is it's not a cake or a pie, Dean. That's the entire point of it.
Aha.
Yeah. Cake implies that the filling is flour. Pie implies that the filling is some sort of fruit or vegetable or meat or something. And a cheesecake comes from more of a set fat lineage, more close to it's in the custards and
definitely asked the wrong
puddings,
person.
family taxonomy rather than a cake or a pie.
Right.
So I said you made a mistake when you picked cheesecake.
No, actually, that was
good.
That was good, Guthrie.
Right. So that's my point, right? So logically, if you think about it, it's a goofy example, but
it's a great example. So if I'm looking for cheesecake and my choices are, cake, pie, and custard.
Right.
As my categories. Right? What am I gonna do?
The other way to think about it, conversely, if we really want to do one other level of abstraction here, is the difference between all those is how does it become firm? How do you take things that are soft and bind them together in a form? So with regular cake, you're using the proteins of the flour and maybe some egg. Mm-hmm. Right. So like what are in a pie situation, you're really not. You're using the sugars to become.
But this is exactly the problem we have in interface design, because you're going to get these domain experts, right? And they're going to tell you, oh my gosh, no, you can't design the interface that way, because actually a cheesecake, it was the binding of the, right? And they want to design the interface based on their knowledge.
Right.
But, the regular person going to order a cheesecake doesn't have that domain expertise at that
that's
level.
Right. It's on the consumption side. And I think that, if you think about a cake is a flour confection and a pie is a filled crust, right? So a cheesecake is really
should be called a cheese pie.
it's a cream cheese pie.
A
Is
cream
what it is.
cheese pie. All
It's
right.
by no
And
means
that's
a
what
cake.
we're going to call it
That's right.
in the order form, because that's what it is.
But nobody. So the
But
mental
nobody
model of the
will
users,
find it.
That's right. So that's where we're going with this. And not only will nobody find it, but from both a technical and design standpoint, again, there is this idea of inheritance, right? So you inherit these attributes from the parent class of the thing. And so, you have to, the cream cheese pie might be pure logic, goofy example, and you can logically argue for that, but there's no earthly reason you would ever use that language. And the problem remains, where do you put that in the taxonomy, right? Which is not to say that everything we do from a design standpoint is about taxonomy and information architecture.
But a lot of it is. Some of it is.
It's related. And, and particularly when you get to the relationships and the semantics, there's a relationship between an information architecture taxonomy and an object model. The object model has a lot of complexity built into that. But anyway, so and this gets back to the whole idea I touched on a couple episodes ago about semiotics as a way to think of this, because you've got the three dimensions of that are syntax, meaning organization, semantics, meaning labeling, and pragmatics. How are the things used? And the cheesecake is used in its own way.
Another very tricky one is, is ketchup a solid or a liquid? Right, because it bedevils everyone. Right, because it's sort of neither.
It's mercurial.
Or Windows is, glass is technically a liquid, but not really.
Well, that gets into state then.
Yeah.
So now we can have the state conversation about objects. Anyway, so we wanted to get, I think, in this episode from the object-oriented programming and technical to the design side of the fence. So objects and views. So Susan, let's talk a little bit more about that and maybe get a little bit more concrete in terms of objects, views, and how that works from the design side.
Yeah, I like the conversation we just had, and I like some of the examples because I think it points out the importance of this thing that, I like to call the conceptual model. The importance of making these decisions before you start to put together screens and pages and voice interfaces. And I think there's two main things we're doing when we do conceptual modeling. And to me, before you go into Figma and start creating a screen or a page and putting this here and that there, there's two main things you need to know. You need to know what is the conceptual model you're going to use. What are the objects? What are the views people are going to have on those objects? What are the actions they're going to take on the objects? What are the attributes of the objects? What are the relationships between the objects? And the other thing you need to know, which is related, and you go back and forth between the two, is what is the task that this person is trying to do, and what is the order of the task? What do they want to do first? What do they want to do next? And those two things get married together, the objects and the tasks and the task flow, which has lately been called user flow. Although it's not a user that's flowing. It is a task the user is doing. But those, at the heart of it, that's what you're trying to get a handle on in conceptual modeling. Because if you have that, if you know your whole object view structure and you know the task flow, then you're ready to start designing these screens. And if you don't know that and you haven't worked through that and you haven't ironed all this out and you just jump right to designing screens, I can guarantee you're going to design screens, and either A, you're going to have to make a gazillion changes to those screens before you're done, or B, you're not going to make a gazillion changes and you're going to end up with an interface that people can't learn or can't use.
So, for the purposes of trying to make this a little more concrete for our listeners, and at the risk of completely blowing up our podcast here, how would you feel about a little real-time analysis?
Uh-oh. Go ahead. I'm ready.
Well, I thought we could look at something together,
Yeah.
and we don't, we can.
A
just
lot of
talk
people
about it
are
individually.
listening,
Yes.
not looking.
Well, but they will look at this afterwards, or maybe
Okay.
as they're
Yeah,
listening.
go
be
ahead.
like,
Go for it.
play along. So I was thinking about this, this morning as I was looking at my notes and thinking about, well, how do we talk about this and
Yeah.
and try and get more concrete. So if we take an example, it could be anything that's common, that we would both have common ground, and that most of our listeners would have common ground for
Yeah.
understanding. So, Amazon.com or Spotify or something.
Yeah.
Microsoft Word, something that's ubiquitous, right? And we can look at that together, you and I, and talk
Absolutely.
a little bit about this.
Let's
You wanna
pick
do it?
let's pick Spotify.
Spotify. Okay, Spotify
Yeah.
is our weapon of choice.
Yeah.
That's everyone loves to pick Spotify.
Oh, okay. All right.
Is that all right with you then, Guthrie, that we pick it?
I don't care. It's you guys do what you want. I'm just telling you that. As part of my job, I've interviewed hundreds and hundreds of college UXers, or people recently graduating who are doing UX, junior UXers, and everyone's capstone project is always Spotify.
Really? Seriously?
Yeah, like 65% of the time they've
That's
picked
funny.
Spotify as their case study example.
Okay.
So
It's got cards. It's got there's interesting
It's just,
objects and views.
and most people
It's
will
not
know about it.
Yeah, okay.
Yeah. It's
okay.
It's
All
got
right.
different
Well,
apps.
so I just fired up Spotify, so I'm
Yeah,
not
me
looking at the
too.
camera. I can't see you. So
Okay.
if you need me, just holler. But here I'm looking at Spotify. I'm on a Mac. I'm looking at the app, right?
Now I'm on Windows.
Okay. So we'll see if there are any distinctions there. You have your.
I can also do it on my phone.
Yeah, that brings up special cases. Maybe we can move.
I'm going to do both. I'm going to do both. Go ahead.
Okay.
Hey
all right.
guys,
Parallel tracking. Yes.
What?
you do know that I can just share Spotify with you if you want.
You mean on the screen?
Or you mean like one license? We all use the same account. Oh, I see. You want to do that.
Look at that.
Okay.
Okay.
All right. Well, we can do that. Except I
Go
can't
ahead.
see the bloody thing. But
Go ahead.
oh wait, I can enter full screen mode. That's magic. Okay, very good. This will work. All right. So Guthrie, you are sharing. So if you look outside of what you're sharing, there is a menu at the top, right? And so,
by the way, this is the new Spotify UI. They have this is recently did their big rolled out update. So
okay.
just saying.
And I am getting now. I've completely lost all of my windows, so I have no idea where you are, Guthrie. But I'm going to look at Spotify and come back to that. So what I'm seeing is in the upper left, a big home button. Very nice. We like to have that. There is a search. Very nice. And then there is a your library, and then a menu that scrolls. It says playlists, podcasts and shows, albums, artists, etc. And then there's a list under that. And then in the main area seems to be an ad and seems to be recently played things. And then on the right seems to be, I don't know, seems to be recommended stuff from what I've seen to before.
Maybe.
All right, Susan, you take over while I try and find where you guys are in my mess of tabs here.
Well, I think one of the
there you are.
If we are now, Dean, did you want to look at this in terms of objects and views?
Yeah. So first of all, let's deconstruct this and say, well, what are the objects we're dealing with here?
Mm-hmm.
Oh, Guthrie's got a different view than I have. Interesting.
That's what I said. I have the new. I have the new one, so it is different.
Okay. Well, this brings up a real. So as I was talking through what I just saw, it was literally labels, home, search, your library, playlists, etc. Guthrie, what you're showing, the toolbar, right, that you have the icons on the left, those are not labeled. So this is an important. People don't talk about this. I don't know actually where this is in the literature. This might have been something I picked up early on from doing it and working with other people who were steeped in this stuff. But there are implicit and explicit objects, right? Like not every object says, "Here, I am a song list," right? It's just there and it's not labeled, and you have to get the idea of it from how it is presented. So that's kind of a
Yeah,
tangent, but
what I find interesting about what's on the left, the menu. All right, so here's some things I find interesting. First of
Yeah.
all, there's when just looking at the entire screen, there are objects on here, and we are looking at a view of different objects, but the labeling is not clear at all. So the
Right.
objects are not labeled. So some of them are, but not clearly. Like the main labels on the screen are on my screen when I bring up Spotify. Let me see if that's true of Guthrie's. Yeah, are things like recently played new indie playlists. That's what Guthrie has. Good afternoon. Okay, that's a label. Good afternoon. It's like what the heck, what does that mean? Good afternoon. And by the way, on mine it says good morning because I'm an hour earlier. But like, that's not a thing, right? And then I have a label that says made for Susan Wineshank, right? Which is all the daily mixes and stuff. But basically you have a lot of stuff on the screen, and it's not clear what object you're looking at.
Well, let's zoom out from the not zoom out, but let's move from the heuristic evaluation in real time to deconstructing the object model, right? So let's say they came to you and they said, "Hey, we want to completely redesign this from the ground up," which, judging from what you just said, might not be a bad idea.
Hold on.
Okay, well, wait a minute. Let's continue this track, this line of thinking here. So if we were to do a conceptual object model for Spotify,
what do I think is in here, or
what are the things?
I think there are playlists.
Okay.
Because I did expand. I had my library collapsed, so you can expand it.
Yes.
Okay.
Okay.
I think there are playlists. I think playlist is an object, might be a sub object. I think there's a library object.
Mm-hmm.
I think there are it's interesting. I think there are songs.
Mm-hmm.
I think there are I think they call them albums.
Well, we used to.
No, but I think they do call them albums.
There are. Yeah. When people
No, I think they
albums.
call them albums.
No, I think
Yeah. But
there are artists.
Mm-hmm.
There are albums and artists. There are playlists. I would say that some of the things here are views of those objects. So, for instance, the collection of liked songs, okay, I would say is a list of songs. So songs is an object, and songs is a particular view.
Give you guys a hint
about what?
When you search for something in Spotify, it tells you exactly what the objects
are,
because
it says artist, playlist, songs,
and so you
genres.
can sort by songs, and it'll show you just the songs. You should sort by playlists.
No, I don't know. No, those aren't objects.
I'm just telling you, this is what Spotify thinks.
Maybe, but for instance, they have genre. A genre is not an object.
Genre is a playlist.
Right. So this gets to the whole.
No, genre is not a playlist.
What is genre?
This gets to the distinction between the information architecture and the object model, right? But because we can go crazy with this, is like we could go to 17 episodes with continuing this, but I want to take it back up a step just to try and give the people who are listening who have never done this before some insight into the thinking. So let's go back to kind of the first few things that you said: playlist, library, albums, artists, songs. Leave it at that to start, right?
Yeah.
So the thought process, the object-oriented thought process, is to say, we have these things. How
Yes.
have we derived these things? Ideally from user research.
Yep.
We've gone through some sort of narrative from the users about their mental model, how they think about these things. We have isolated in that language the nouns, which are candidate objects,
Yep.
right? And the verbs, which are candidate tasks or actions. And we create a model that's going to inform our screen design. And that model it can be just boxes and arrows. The most refined way to do that is probably in UML, but if you're just doing boxes and arrows on a whiteboard, you've got playlists, libraries, songs, albums, artists, and the thought process is, what are these things? Can we define them? What should they be called using the user's language? And then critically, in the early stage, how are they related to one another? Because
Yes.
ultimately, what I want to do is I want to play a song, right? I want to listen to a song. But I might, in my narrative and my nouns and verbs thinking, say, well, you know what? That song is something that I choose to search for. I get a list of versions of that song from different artists. I'll pick one, I'll put it in my playlist. So add becomes an action. Add to what? Add to a different object, an object called playlist. What is the count of those things? How many songs can I have in a playlist? How many playlists can I have? We have to identify the number of those things. So we do this analysis of objects, attributes, actions, count, all of these things about an object, and then define the views in order to serve the information up to the user. So that's kind of the thought process
Yeah,
that we want to go
and I do want to point out that it's so it's interesting because when we're designing something, we have to think about what is the user's current mental model, and we want to make it so it fits with that. But it doesn't have to be 100% if we have a good reason to do something slightly different. And the example I want to use here, since we're talking about Spotify, is there was a moment in time with any of these Spotify or Spotify-like programs where if you ask the users about their mental model about listening to music, the word playlist would never have come up. There was no such thing as a playlist. There were maybe albums, there were maybe CDs, there were artists, but because you weren't streaming music this way, the idea of a playlist. So if you had, just designed it based on the user's current mental model at that point in time historically, you would never have introduced the concept of a playlist. But you can build in things that are new, but you have to know when you're building them in that it is new, and you have to think about, therefore, should we do this? What is it? What do we call it? And and test it. And if it's a useful object and or a useful view, and you've named it well, then your testing will show that people go, oh, I get it. It's a list of songs I like. So you can build in new stuff, but you have to know when you're doing that you are purposely choosing something that isn't part of the user's current mental model. And, then how are we going to make it easy to learn and understand?
Yeah. And this really describes what you just went through, describes the relationship between analysis and design, right? And there's a space for innovation in there. So if we're doing an analysis, we're doing research, we're analyzing our users'
what is
world
their
and their
current mental model? What is their current task analysis? And then, well, what's the future mental model that we want them to have? What's the future task analysis?
Right.
How do we get there? Yep.
So the process includes that analysis of current state.
Yep.
And then it includes a place for the creative work of what would be referred to as a value add object. You're sitting around with the team and the whiteboard and you're spitballing ideas and you're like, hey, what if we had this thing called a playlist? And then somebody else is going to say, well, let's use the label collection instead of playlist. Nobody knows what a label is, or what that label is. So then you get into the semantics, right?
Yep.
as well. And so there are kind of two steps to the process. There's the analysis of current state, there's the designing of the future state, and then all the way through there's healthy respect for semantics.
And I think one of the things that, and I know we're at time, so I'll try and wrap it up. One of the things that is I just is really important is that you make these decisions and you map this out before you've designed the detail screens. Right. You actually don't want to design the detail screen and then back up into what is the conceptual model we've created. You want to think about it ahead of time and then design based on that. And then there's one other thing I want to say, because I told you I had an argument. I want to mention what that is. So I want to make a distinction between when we were talking in our earlier episodes on this topic, and we were talking about graphical user interfaces and when objects started appearing on screens, when Windows was first developed, and now there were buttons, and now there were, boxes, right? I mean, if we're looking at the Spotify screen, there's boxes and, things to click on, right? And I can click on the little heart icon, and, that's the whole idea of a graphical user interface. And a lot of the design we all do now is based on designing for this kind of graphical user interface, but not all of it. I mean, if you're doing a voice interface, you don't have buttons, So this idea of a conceptual model, this idea of objects and their relationship and the actions you take on objects is not necessarily directly related to graphical user interfaces. So before graphical user interfaces really came on the scene, when we had, and I don't know what, 1% of the people listening remember this, but maybe you saw some old screens in old movies or something. Before this, you still had screens and you had data on screens. You just didn't interact with things by clicking on things.
Right.
You didn't necessarily have a mouse, but you could still make your way through menus, right? You could still, and we did, make object and view and action decisions because and you can do the same thing with a voice interface, even though you're not clicking on anything.
Right.
So this is not, I wanted to kind of decouple a little bit the dependency. When we talk about objects and views in interface design and making these decisions, we are talking about a conceptual abstract model that then influences how the user does what they do, what they call things, what the order of events is. And that is separate from whatever the interface is you decide to use.
And separate from the technology, right?
It's separate from the technology.
You can create and should create an object-oriented model and go through the object view exercise, even if you're using a procedural language. It doesn't
That's right.
require
object-oriented programming. Right. Doesn't require a visual interface.
Yeah, right. That doesn't even require a visual. You do the same thing.
Do it, now, same thing with voice.
But I will say, from a voice standpoint,
yeah.
If you then, we're looking at a playlist now. We're looking at songs. If I want to play funky bits, looking at what, if I want to play Guthrie's funky bits here on the screen, what do? I identify an object visually, right? This is a matter of perception, physical perception, and I click on the thing. And there may be in proper object orientation, various actions that I can take, direct manipulation that I can take directly on this thing, right? I could click on it to play it. I can drag it into my playlist. Where
That's
I don't
right.
even know if that's possible. Could you? We should experiment with that. Can you drag that into a playlist rather than click on it and use a menu command to move it? But whatever, I can take that action on the thing. I am in a visual interface. You're always dealing with objects and actions. In a visual interface like this, I would notice that the Funky Bits song is there. I would click on it and it would play, or I would click on it and then mash play, however it operates. But it is object, then action, right?
Yes.
If this were a voice interface, hey, computer,
Yes.
play Funky Bits.
Yes.
It's action, then
Well, and that,
right?
yes. So that's why you do, when you're designing, you have to, when you're doing the conceptual design as well as the detailed design, you have to know what is the expectation of how this, how this is going to be used. Because as you said, if it's a voice interface, there's all kinds of things I have to do differently. I mean, even, we know, for instance, that with voice interfaces, you can't have as many choices because the audio memory is really relying on memory. If I'm looking at the screen, I don't have to remember all my choices because they're sitting there on the screen. But if you're telling me what my choices are and you're reading them to me, then I've got a totally different memory problem now, because I don't have the visual cue. And if I'm on my phone, all the interactions are different. I'm not going to be, dragging something over and dropping it. So, it's just not, I might be doing swiping, right? It's different. And you have to know that. And that will affect and should affect your conceptual model decisions. So that, you have to know when you're designing the conceptual model, what are the intended ways that this is going to be used, and you got to take that into account as well. And that's what makes our job so fun. All right, we are absolutely over time, Guthrie. This is a long one. You got to make us stop. Make us stop.
Never. That's fine.
Did we do it, Dean?
Oh no, we're not done. I mean, we can be done.
No. We'll come back.
Do another one. You gotta do another one.
Yes, we can do another, or we can end the series here, or we can do another one.
No, Guthrie's like, nope. You're doing it. You're not done. Right. You're not done. You haven't wrapped it up in a bow. We'll be done when
you have nothing left to say.
Well, that'll take forever.
Okay. The year 2072.
You can change topics.
I want to go back to in our next episode then, just so we know where we left off.
Where are we going?
We could explore this notion of one model and multiple implementations, right? You have your one object model, and then you might have a different set of views or different implementation for the desktop, for the mobile, for the voice, whatever. But, since most of your listeners are probably working in a visual interface, we never really got into a couple of key topics around object-oriented design, such as metaphor and skeuomorphism.
Let's go there.
I'd like to pick up there and get into the real designerly stuff.
Metaphor and skeuomorphism. And you get extra points if you can, don't do it now, if you can spell skeuomorphism when we get back together.
It's a great Scrabble word.
It would be challenged by my Scrabble people. It has to, that is crazy. All right, Guthrie, take us out. If people are still listening and have any questions or comments, how do they reach us?
You can email us at info@theteamw.com.
All right.
That's the best way to do it. Other things to note.
Yeah.
We'll have to mention this soon as well. We are finishing up writing a second edition.
Yeah, of one of my books. Yeah.
So that will be coming out shortly. So keep an eye out for that.
Yeah.
And we're also we're restarting up some other stuff. Maybe get the newsletter restarted, sprucing up the blog. So there's sort of a summer projects coming into fruition. So we'll keep an eye out for those things if you're interested about other Team W stuff. All right.
Thank you, Guthrie. Thank you, Dean.
Thanks, guys.
Thank you, Susan. Thank you, Guthrie. Bye.
Bye.